Hello everyone, my name is Florence Weiss from Pompeu Fabra University, and I am delighted to present this study in collaboration with Charlotte Alazar-Guyou from Toulouse Jean Jaurès University and Pilar Prieto from Pompeu Fabra University and the Catalan Institution for Research and Advanced Studies. This study deals with the role of embodied, melodic, and rhythmic training in L2 pronunciation. First of all, I'd like to quickly mention that the study stems from previous research that showed that pronunciation instruction and prosodic instruction in particular has positive effects on pronunciation. So please refer to the review articles mentioned here to know more about it. However, how to carry out prosodic instruction remains unclear. So this study would like to propose a technique involving hand gesture in order to teach L2 prosody that's rooted in the embodied cognition theory. So in the following, I will talk about the theory of embodied cognition and how it applies to second language learning, more specifically in the context of phonological learning. According to the embodied cognition theory, human cognition is not only realized in the brain, but also in the physical body, as well as in the sensory motor processes that enables humans to deal with their environment. Such theory has great implication for education in general, as shown, for example, by the importance of manipulation when learning science. But the theory also shows important implication in language and language learning. For example, there is evidence from neuroimaging studies that motor areas in the brain are activated both when listening to speech and when speaking. And in the same way, we can observe the activation of language areas during certain motor activities. But how can we relate embodiment to second language acquisition? Well, from observational studies, we know that teachers and learners use gesture in the classroom to express concepts or to communicate. And from experimental studies, there is evidence that spontaneous and non-spontaneous gestures have positive role on word recall or on grammar learning. So what about phonological learning? Well, embodied pronunciation training has been studied from different angles. So first, observing and producing rhythmic beat gestures accompanying speech during a short training session helped reduce accentedness. Then, hand clapping on the rhythmic structure of new words also helped reduce accentedness and produce more target-like prominence patterns. And recently, a series of studies have been carried out to test the effect of visuospatial hand gesture. So these gestures are depicting in space specific properties of sounds. For example, pitch gestures mimicking pitch contours have been proven useful for the perception of lexical tones and also for the pronunciation of difficult pitch contours in an L2. Durational gestures have helped participants to better produce long vowels in minimal pairs of words with a durational contrast. And finally, hand articulatory gestures mimicking the bust in Chinese plosives have also helped naive learners to produce these phonemes more accurately. Why do we think that gesture works so well for phonological learning? Well, first, we know that there is a tight relationship between prosody and gesture. Then there is evidence from the field of sign language that there is a visuospatial phonological loop in working memory. And in addition, there is also clear evidence that humans have a visuospatial representation of pitch and duration in their mind. This is high pitch, this is low pitch, this is short duration, this is long duration. So finally, if we think about the parallel between speech and music, we know that body movements are used to teach rhythmic and melodic patterns. So why do we not implement this when teaching and learning the prosody of a foreign language? From what we know of, there is a couple of pronunciation teaching methods that use body movements and gesture to teach foreign language pronunciation. The first one is the Haptic Integrated English Pronunciation Framework developed by Acton and colleagues to teach English pronunciation. And the second one is the verbotonal methods invented by Guberina and which is mostly famous in France. In these methods, there are different techniques to teach pronunciation, but essentially they advocate to teach the prosody of the language from start, because it's believed that prosody is structuring the sentence and that this is essential for further pronunciation development. So notably, the verbotonal methods makes use of logatom and gestures, as you will see now in a short video.
Essaie avec ta. Exactement. Essaie avec ta. Exactement.
So this is a French class, and the teacher is producing some sounds and a gesture. And she's producing a sentence, but she's repeating the same sound, ta ta ta, instead of the words of the sentence. So this is called logatom. And it's useful in order to focus on the prosodic structure of the sentence by getting rid of the segments. And in addition, she uses a gesture all along the sentence to make this prosodic structure visible. So finally, the learner repeats both the logatom and the gesture. So based on previous evidence on visuospatial gesture, we want to assess the effect of this type of gesture at the sentence level. And in order to do so, we will compare three different conditions. Embodied prosodic training with logatom and gestures, non-prosodic training with speech only, and importantly, prosodic training without embodiment, only with logatoms. Then, in order to assess pronunciation thoroughly, we have also chosen to measure both overall and specific pronunciation features. So, comprehensibility, fluency, and accentedness, and segmental and suprasegmental accuracy. Let's jump to the methods. We recruited 75 first and second year students in translation and applied languages from the University Pompeu Fabra. All were Catalan speakers with an intermediate level of French. The pronunciation training program took place during their French class and was carried out in individual translation booths. We randomly assigned them to one of the three conditions: speech only, non-embodied logatom, and embodied logatom. In this image, you can see one of the instructor in the non-embodied and embodied logatom conditions. At the top, the instructor is not moving her hand, and she's simply repeating the logatom da. Just below, you can observe how the hand of the instructor is following the pitch movement over the logatom series corresponding to the sentence Je suis désolé, votre lettre n'est pas là. Je suis désolé, votre lettre n'est pas là. So the training paradigm consisted in two tasks: reading aloud a dialogue and training on specific sentences from this dialogue in a repetition task with three different instructors. In total, we used 9 dialogues, 3 in each session. And for specific training, we used 5 sentences from each dialogue. So a total of 15 sentences were trained in each session. For the pre and post test, we used 3 dialogues from training. one from each session, plus an untrained dialogue to see if training effects could be generalized. French proficiency was controlled thanks to a questionnaire, and at the end of the training program, we asked participants if they liked the training, if they felt they had improved their pronunciation, if they would like to repeat the same kind of activity in the future. So here is an example of dialogue. The length is 8 turns, but the length may vary a little from dialogue to dialogue. In this one, a girl is asking her father if she can go to the movies with a friend, but her father refuses, so they have this argument. Let's now look at the procedure. I'll explain step by step how it worked. So let's start with the whole prosodic training program. It took place during 5 consecutive weeks. First, the 75 participants took part in the pretest, which consisted in a dialogue read speech task. Then they were randomly assigned to one of the 3 conditions, and during the 3 following weeks, they took part in the pronunciation training program during their French class as an individual activity which lasted around 30 minutes each time. What happens during each training session? So learners worked with 3 different dialogues, and for each of them, they followed the following procedure. First, reading silently, then reading aloud, then the audiovisual training with a repetition task of 5 sentences with different materials depending on the condition. This was followed by reading aloud, then watching a video where native speakers perform the dialogue in a natural fashion, and finally reading aloud one last time. Let's now look at the sentence training sequence. So during audiovisual training, as mentioned earlier, participants watched the instructors and repeated what they were saying and what they were doing. So for each dialogue, 5 sentences were trained twice. Let's watch an example for the sentence presented on the screen. Mais le facteur n'est pas rentré de sa tournée. So in the speech-only group, participants watched the sentence on a black screen and then listened and repeated the sentence twice.
Mais le facteur n'est pas rentré de sa tournée.
In the non-embodied logatom group, participants listened to and repeated the logatom. And then they also listened to the sentence and repeated it once.
Da 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 da.
Finally, in the embodied logatom group, participants listened to and repeated the logatom, and in addition, they copied the gesture performed by the instructor while speaking. And then they also listened to the sentence and repeated it once.
Da 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 da.
Pronunciation of the dialogue read speech task at pre-test and post-test was assessed by perceptual rating. We asked 3 native French teachers in Catalonia to rate participants' spoken dialogues on a scale from 1 to 9 and for the 5 measures. So this represented 16 hours of work. So we divided randomly the oral productions of the participants in 16 batches of 1-hour durations, and they had to complete the rating within 1 week. The rating obtained were tested in terms of effect of type of training on each of the 5 pronunciation measures, thanks to 5 generalized linear mixed models. As fixed factors, we included group, session, and familiarity and their interactions. Let's now look at the results. So for the 3 measures, of comprehensibility, fluency, and accentedness, we observe a significant improvement from pre-test to post-test in all the groups, showing that training pronunciation is helpful for training read speech. In addition, we found a significant interaction between group and session for the accentedness measure, and post-hoc analysis showed that the embodied logatom group improved significantly more than the speech-only group for this measure. No difference was found between trained and untrained dialogues, showing that participants were able to transfer what they gained from training to a new item. Regarding segmental and suprasegmental feeders, as before, we observe a significant effect of session in both measures and for the three groups. In addition, we find a significant interaction between group and session for the suprasegmental measure, with significantly higher gains in the embodied logatom group than in the speech-only group. Again, no difference were found between trained and untrained items. What about learners' satisfaction? You can see that learner satisfaction was quite high in all the groups. The speech-only group reported the highest satisfaction in the three questions. In the non-embodied and embodied logatom groups, the results were also satisfying, showing that despite the novelty of the task and the eventual awkwardness of repeating logatoms and doing gestures that were not known, were not penalized too much. So to sum up, our results show that all the groups improved significantly between pre and post-test, but that training with embodied logatom added an extra advantage to improve accentedness and the pronunciation of suprasegmental feeders compared to speech only. So these results underline the direct benefits of embodying prosody on the pronunciation of suprasegmental feeders. Gestures may have helped learners obtaining the adequate mental representation of the target prosody, thanks to motoric perception and action coupled to the visuospatial phonological loop. Our results also have implication for the language classroom and pronunciation teaching methods. We provide evidence of the efficacy of embodied logatoms, at least for oral reading, as a useful technique as used in the verbotonal methods to teach L2 suprasegmental feeders. Regarding fluency and segmental feeders, our results are in line with Al-Azhar 2013 and Al-Azhar et al. 2018, who did not find an advantage of the verbotonal method compared to the articulatory method. However, by comparing the results of the three overall measures, we can observe that fluency and comprehensibility scores were already quite high at pre-test. So it may be the case that participants with lower proficiency in French would benefit more from embodied training. A second important implication of our study is that our prosodic gesture, embodying the rhythm and the melody of L2 sentences, amplifies the list of tools available to the foreign language teacher who wants to teach pronunciation with gestures. So we had hand clapping, pitch gesture, directional gesture, hand articulatory gesture, and now we also can add prosodic gesture. I'd like to mention some limitation to these studies, which I think are aspects that should be dealt with in future studies. So first, our study looked at the effect of embodied prosodic training on oral reading, but looking at spontaneous speech would be and should be the next step. Then we associated the gesture to logatoms in order to be able to claim that it is a gesture itself that makes a difference. But what would happen if we associate the gesture to sentence itself? Would it still trigger beta GANs? So, an interesting property of gestural training detected in previous research is that gesture help retain the gains over time, while it's not the case in speech training conditions. Therefore, it would be interesting to check if this is also the case with our training program, especially for the measures that didn't show a difference between groups. Finally, other recent studies have underlined the importance of appropriately performing the gesture during training. So we believe that controlling the gesture performance during our training sessions may also have yielded interesting results. To conclude, going back to the embodied cognition theory and embodied learning, I'd like to say that this is an exciting new field to explore in second language acquisition. In addition, it opens new pedagogical horizons for language teachers, not only in terms of gestures, but also whole body movement. So, for example, for prosodic instruction, we can imagine walking to the rhythm of speech or jumping on prominent syllables. So, well, this is the end of this presentation. Thank you very much for your attention. I'll gladly answer your questions now. Bye.